8 and 9 are application sections. So it's connecting quadratic functions with real life scenarios in which you could use a quadratic equation to solve for the problem. So lesson 8 looks at using a graphical approach, whereas lesson 9 will look at an algebraic approach. So things to recall with in graphing. You can use a graphing calculator to find the min and the max value. That's your vertex, is basically what you're calculating. So when you have a quadratic, you can use the maximum or the minimum feature of the calculator to find the vertex. And the vertex is useful because that gives me that p and that q value of my equation. So what you would do is you would enter y1 into, or the equation into y1 and graph it, and then access that calculation feature by going second trace. When you access either the min or the max, again the calculator is going to ask you for a left and a right bound, because the calculator wants to kind of be told, I want you to look in this part of the graph, otherwise it's going to look all over the place. And that min and maximum, in a quadratic I only have one. But if I drew a graph that had a shape like that, I have a couple of maximum points and a couple of minimum points. So if I wanted to know what this one was specifically, that's the purpose behind the left and the right bound. Once you've done that, it's going to ask you for a guess. You keep pressing enter until it actually says maximum or says minimum. And then that max value or that min value corresponds to the y coordinate. So if we look at the first example, the height in meters above the ground of a projectile at any time in seconds after the launch is defined by the following function. So when we're doing these questions, probably the most difficult part of the graphing process is coming up with an adequate or suitable window setting. So if I look at this equation, the function is h of t, which is height as a function of time. So I would type in negative 4x squared plus 48x plus 3. Now if I think about this logically, time always goes forward, okay? We don't generally think of time in a negative sense, which is why when I look at my grid, I don't have very many or a lot of space in the negative for time. H refers to my height. Well, at time 0, I have a height of 3. It's my constant value. And if it's a projectile goes up and then it comes down. So if I look at my window settings, my time, I can start at 0, and perhaps we just start off with 20 seconds and see where that takes us. And then my y values, again, I could start at 0, or if I wanted to start at -5, and I'll show you why you might start at a -5, and then maybe go up to a height of, let's try 50 and see what 50 would do. And then my scale could be going up by 5s. So if I press graph, so what I see is the graph going up and coming down. So my 20 seconds was probably a little too high. I could probably bump that down to 15 seconds. But my height, I need to increase. 50 was not high enough. So I go back and I make that adjustment. Change my x max to 15. If I wanted to change the scale to 5, I won't have as many tick marks, which might not be as distracting. And then try 75. Graph it again. So I still don't have a high enough. The other thing that I could do is I could go look at my table. And when I look at my table, after 6 seconds, I have a height of 147, and then at 7 seconds, it comes back down to 143. So that tells me I'm going to go up to almost 150 meters. So I go back to my window settings, and this time now, instead of just going up by 25 or trying to guess, I could put in 150. This time, maybe change my scales to be tens. And now when I graph this, I can now see the entire shape of the quadratic. It's important that I be able to see that vertex. So then the first question, sketch the relevant part of the parabola on the grid. So copy this into the grid and then write your window settings in here. So when we go to write our window settings, we start off with our x's and we use a square bracket. And it's the same format each time. The minimum, the maximum, and the scale, which is the first three that are on that window setting. So for us, I think it was 0, 15, and 5. And then our y's, we went -10, or sorry, no, we went -5. -5 to 150, and we went up by tens. And then that gave us this kind of a picture. And from my table, I know that 150 is just a little bit above that maximum value. And so then if I wanted to, I could split these into thirds. So I get 100, and I get 50. And then I know 15 seconds was a little bit outside the marker. So again, I could split this up into thirds for my 5 and my 10. So question B says, find the height of the projectile 3 seconds after the launch. That would be time equaling 3. So instead of putting 3 into the equation and solving for it, I can press the trace button on my calculator, press the number 3, and if you notice on the screen, it'll come up x equals 3. Press enter, and it jumps to 3, and it gives me a y value of 111. So 3 seconds after launch, the projectile was 111 meters in the air. So the height would be 111 meters. Question C says find the maximum height reached by the projectile. So that's where I use that maximum feature. So it's second, calc, choice number 4, which is maximum, and then it says left bound, right bound. So left bound means being on the left side of that maximum. And if I watch my y coordinates, I see that they're increasing. And then when I see that they're starting to decrease again, I can press enter and then I can get the right side. Again, I look for the 2 arrows to be pointing to each other because that tells the graph where to look. I press enter one more time and I get a maximum of what? What's my y coordinate? 147. So the maximum height reached by the projectile was 147 meters. How many seconds did it take for that maximum height to be reached? So if I go back to this picture, what's my x value? So my y value was 147, my x value was 6. Now, this glitch in here, because some of you might have 5.999, some of you might have exactly 6, and some might have 6.0001. It's a glitch within the resolution or the programming of the calculator. I would take this to be 6 seconds. Okay? So the time would be 6 seconds. Question E says, what was the height of the projectile at the launch? So that's at time 0. So at 0 seconds, what height did the projectile start off at? 3. And I can get that from my equation because it's the constant term. These would be zeros, so I'd be left with 3 meters. So that means that the projectile was launched off something that was already 3 meters in the air. So maybe it was from the top of a building. And question F says, determine when the projectile hit the ground to the nearest tenth of a second. So where it hits the ground is right here. What feature of the graph would allow me to find that spot? The 0. So I'm going to find the 0. And this is why I said start with a -5, because then you can see the x-axis to be able to do your 0. So my 0, I have to be on the left side. So I watch my y values, and when they start to get smaller, so there's my left side. And to be on the right side means that my y values have to become negative. So I might not be able to see the cursor, but as long as my y values are negative, I have a positive and then a negative. I don't want it to guess. I press enter one more time. And what I get is 12 point, to the nearest tenth, 12 point what? 12.1. So I get that t equals 12.06, which becomes 12.1 seconds. Okay, so let's look at the next question. This is a realistic question that a sports franchise would possibly consider. A struggling hockey club had 7,200 season ticket holders. We won't name names, but this could possibly be the Oilers. The owner of the hockey club has decided to raise the price of the package of season's tickets for the new season to generate more revenue. So the existing price is $1,400 for the season. Before they raise the price of these season tickets, they hire a marketing research company to do a poll and find out. Because for some people, there's always a tipping point. If the price goes to this, I will not buy this anymore. So if I raise my price from $1,400, how many of these 7,200 season ticket holders are going to say, yeah, no, it's not worth it? And that's what the marketing research company will determine. So what the company came up with is that for every $25 I increase my package, I will have 100 season ticket holders that opt out. And even though I'm raising it by $25 and I'm losing 100 people, I'm still going to make money. Because if we just do that one calculation, I lose if we start off with originally, 7,200 times 1,400 tickets. So that are not 1,400 tickets, $1,400 per package. Gives me $10,080,000. That's how much I'm generating currently. If I change that to be $14.25, I up the price by 25 bucks, and 100 people say, nope, not buying it. So now it goes down to 71. If you do that calculation, I actually make $10,117,500. So I make an extra almost $40,000 just by increasing the price by $25, even with the loss of 100 people. Because I still have 7,100 people that earned an extra, or that made me an extra $25. So it would actually still be financially viable to increase the price. So if the price increase was to be multiples of $25, this is how we could solve this question. Let x be the number So to get my revenue, which I'm going to call R of X. So revenue as a function of X, as a function of those increments, would be the cost times the number of tickets sold. And question C says, determine the price of a package of season ticket holders that would generate the maximum revenue. So I'm going to graph this. And this is the tricky part when I go to graph this, is going to be determining the window settings. So if I go Y1, and I can just put it in its factored form, bracket 1400 plus 25x times 7200 minus 100x. Now go to your table of values. If I go second graph. If you look at these numbers, this is 1.02 E7, which means times 10 to the power of 7. And it doesn't actually even really change because it's that big of a number. But what it tells me is that my Y value has to be a large number. So when I go to my window settings, I can go from 0 to probably no more than 10. Because 10 increments, that would be, well, if I think about this, 10 increments would be a loss of 1,000, and it would be an increase of $250 per package. So I start off with 10 increments. My Y values. I still want to start off at -5 or a negative value just so that I can see that x-axis. But my maximum, we've just determined, is 1.02 times 10 to the power of 7. So let's make it 1.03 times 10 to the power of 7. And for your scale, I want you to put 0. 0 means that there is no scale. So I'm not going to have any tick marks along my y-axis, which I don't actually need in the course of the graph. So now we go to graph this. Not really getting a good shape, am I? Okay, so let's adjust things. Maybe go up to 15 instead. Because I did see a slight change, but I didn't see the change come back down. And instead of making this 10,300,000, what if we just made it a simple 11 million? So now I can see that the graph went up and came down. It's not great, but it works. If I changed my window settings, I think if I went up to probably 17 million. Now I get a straight line. If I wanted to see this as an actual curve, the best way to do that would be if I kept this at 110 million, or sorry, at 10 million, and if I changed my minimum, instead of being 11 million, if I started off at, let's say, even 8 million. Oh, I need one more 0. Now you actually start to see a curve. If I tighten that up even further, make this 10 million. There's an actual curve. So all this means is when I go to sketch this on the graph, I'm going to have a graph that goes like that. I'm not going to label anything on this graph right now because the numbers for my y's are just too large. I'm going to leave it just as a sketch. This is my increments, and this is my revenue. So question C says determine the price of a package of season ticket holders which would generate the maximum revenue. The maximum revenue is generated right here. So find the max value of that curve. So that's second calc and max. So if I watch carefully my numbers in here, and I watch as they increase, and then I look for them to start to decrease again, then I have my two arrows pointing at each other. And what does my x value equal? $8. So, and what's the maximum revenue at 8? I get 10 million. So then my x value equals 8, and my y value, which is my revenue, is 10,240,000. So the price of my season's tickets would be the $1,400 that I started off with, plus 8 increments of $25. 8 increments of $25 would be how much? $200. $200. So what would be the total cost? $1,600. And how many season ticket holders would I have under this new plan? How would I determine that one? So it's 800 fewer people. So how many season ticket holders would I sell to? $6,400. And then question E says how much more revenue would I generate? So my original revenue is what I calculated up at the top. That was my 1,400 times 7,200, which was my $10,080,000. My new revenue was the Y value of that maximum point, which was my $10,240,000, which is the same as taking $1,600, because that's the price of each package, times 6,400 packages. So the difference between these two amounts would be how much? What'd you get? $160,000. That's how much more money I would make. And this is an example. This is a marketing question that a number cruncher working for an organization such as even the Storm in Grand Prairie or the Oilers or a basketball team, a football team, this is something that they look at. when they are faced with a decision of having to increase prices because expenses increase, they've done a study to find out what is that tipping point. What is the most amount of money I can raise the price by and still have an organization and still be viable? Amusement parks do this. Callaway Park, before they increase their admission costs, would have done a study to see what's going to happen. Or Calgary Zoo would do the same thing. Before I increase the amount to get into the zoo, I'm going to maybe do a quick poll, or I'm going to do a study to find out what losses could be made from it. Because if I increase the price too much, I'm going to lose money. So it's not just an arbitrary, let's up the price by this amount. So the questions that I want you to look at, questions 3 and 4. Question number 3 looks at the reversal. Question number 3 looks at what happens if I decrease the price. Because if I decrease the package, I'm going to actually get more people buying it. So could I generate more revenue with a decrease in price instead of an increase? Question number 4 looks at cost of insurance. Question number 5, I think, is an interesting question, because question number 5 looks at yield and cost for a potato producer. And then questions 6 and 7 are numerical response questions.